14th lecture of the electrostatics. In this lecture, we are going to discuss about the electric flux. What is flux? Flux is nothing but the flow of anything from the surface, from any closed surface, basically. And we are going to discuss about the electric flux. Electric flux is nothing but, let's suppose I take the some area. Let me take some area, any closed area, and then let's suppose this is the electric field lines passing through this area. Yes, it might be the from the outside also, it might be inside, yeah, penetrating them from the surface. And what is electric flux? The electric flux through the surface represent the total number of electric field lines passing through the surface. It is nothing but the electric flux. Then simply the total number of electric field lines passing through the any surface is known as electric flux. Yes, and this can be represented by let's suppose you have a small area. We are interested to find out the number of line passing through this small area, ds vector. Let me because we have discussed in the I think last to last lecture that the area element is nothing but a vector quantity, and this small area vector I am representing it by the vector quantity ds vector quantity. The direction of the vector is perpendicular to the surface. Okay, the area element. Then I represent it the flux, d flux can written this symbol represent the flux. And then ds the d phi, and the small flux through the small surface area that I have taken is nothing but E dot ds. It is simply the dot product between the electric field and the ds vector. And then this dot product will give the electric flux. If you want to find out the total electric field flux, then you have to integrate it, then E dot ds vector simply, and this is the total electric flux. We simply write is the total electric flux. And to represent it by the closed surface, we mostly use the making a circle here on the integration part, and this is nothing but the flux through a closed surface area, and it is nothing but given by this equation. And this integration circle will represent the closed surface. And you can also find out the unit for this is electric field unit is simply Newton per unit charge. Yes, and then the surface area meter square, then unit for this become this. Okay, let me take a one question. This is the question. The electric field in the given region is represented by the 3 by 5 E naught x cap and 4 by 5 E naught in the y cap. It is simply let me take the E vector in this xy plane, because you have only the component of the x and y. Simply then the E vector become in the x direction, the component of the E is that they are giving the 3 by 5 E naught x cap, and similarly in the y direction you are getting the component 4 by 5 E naught j cap. They are E naught is something constant, they have given the value for it. And find the flux of this region through the rectangular surface. They are giving the some rectangular surface that I have taken parallel to the YZ plane. I had taken the some area element. This area is given to you 0.2 meters, and this is parallel to the YZ plane. Then it look like this. Just remember, just to think like that, it is perpendicular to the YZ plane, and then just because they are asking the flux. Yes, flux is nothing but integration of E dot ds vector. Yes, all we have to find out the area element. Let's suppose I take the small area element. Can you tell me the direction of this area? Because it is in the YZ plane. Area is in the YZ plane parallel to, then what is the direction of the area element? It is basically perpendicular to this plane, this surface. Then perpendicular direction is x cap. Okay, remember it, because ds vector is in the x cap direction. Just the next slide. The flux is nothing but integration of e vector. E vector is nothing but 0.5 e naught I cap plus 4 by 5 E naught J cap. It is a basically NCERT question. And dot product between the area. Let me take it first of all area as A only, but direction is just you had to represent it direction also. It is I cap. Then you have to simply uh, let me first take as ds vector only. Okay, after that I will integrate it. And then if you multiply, because in the dot product we have seen in the last lecture, for the dot product you have to simply multiply the corresponding components of the x cap and the y cap. Because there is no y cap, then y cap component becomes 0, and then x cap component you have to compare it, and then you are getting 2 3 by 5 e naught. And then because this is constant come out from the integration, and then I would write ds vector remain inside the integration. Then if you integrate the surface area, the surface area is given to you, then it come out to be only 3.5 e naught. And the area, I think they are giving, just put the value of area and the e naught value, then you are getting the flux, total flux through it. Okay, thank you.